right, 13.7, division of polynomials. Directions here would just be divide. All right, so if we have just a single term in our denominator, so notice we just have 5a, and our terms are separated by the plus and minus sign. So that means in our numerator, we have 3 terms. But when we have a single term in the denominator, the way we would do it is we would take that single term and apply it or divide it into each term in the numerator. All right, so I can rewrite this as 5a cubed over 5a minus 10a squared over 5a plus 20 over 5a. All right, and then we will simplify accordingly. 5 divided by 5 leaves you at 1. Also, don't forget, we're going to subtract our exponents. So 3 minus 1 here would just be a squared. 10 divided by 5 is 2. Subtract your exponents. That'll just be a to the first power. 20 divided by 5 is 4. And then that a would just still be in your denominator. So it'd just be 4 over a. It was nothing that could cancel out in the numerator. So you just leave the a in the denominator. All right. Make sure we're okay with that. All right. All right, trying another one. We have 12y squared z cubed minus 15y z squared plus 6y squared z divided by negative 6y squared z. So once again, we're dividing by a single term. Negative 6y squared z is just one term. And if we wanted to, we could rewrite this with the negative 6y squared z under each. All right. All right, so 12 divided by negative 6 is negative 2. Y squared and y squared, it cancels out. And then here, subtracting our exponents, 3 minus 1 is z to the second power. Negative to negative is positive. And that 15 over 6 can reduce. We'll do it like this. 15 over 6, same thing as 3 times 5 over 2 times 3. 3's cancel. Leaves you with 5 over 2. So that's 5 over 2. And notice, and let's look at these exponents right here for our variables. We have y to the 1 minus 2, which is y to the negative first power. Z is going to be 2 minus 1, which is z to the first power. So don't forget, whenever you have a negative exponent, remember we drop that down into our denominator to make that positive. So that'll be a y down here with the 2 and z up in the numerator with the 5. Another way of looking at that, so I have 15y, 2z's over 6, 2y's and 1z. That's y squared. So one of these y's will cancel. One of these z's will cancel. So you notice the z is left in the numerator, that y is left in your denominator. And so that's what we have right here. So whichever way you decide to cancel, your z should be left in the numerator, and there should be a y left in your denominator. All right. Then this last term, 6 divided by -6 is -1. Y squareds cancel, z's cancel, so you're just left with -1. All right, so that would be your answer. All right, questions on that? Problems, concerns? All right, so let's look at long division, the long division process. So if we want to divide 2,273 by 5, we'll set the 5 up on the outside of your long division bar, 2273 on the inside. And the only reason we're going through this process is because we're going to take this process and use it on our polynomials. So 5 doesn't go into 2, but it goes into 22 4 times. 4 times 5 is 20. Subtract those two numbers, 22 and 20, that'll leave you with 2. Bring down 7. 5 goes into 27. 5 times. 5 times 5 is 25. Subtract, that'll leave you with 2. Bring down 3. 5 goes into 23 4 times. 4 times 5 is 20. Remainder of 3. So your answer is going to be 454 3/5. So you take the 3 and place it over what you were divided by. So that would be your answer. And that same process we're going to mimic when it comes to dividing with our polynomials. All right. Questions on that before we actually try to do it with our polynomials? All right. So we have 2x squared minus x plus 3. We want to divide that by x minus 3. So you take your x minus 3, place it on the outside. 2x squared minus x plus 3 on the inside. All right, so you're going to compare the first terms in each. And you ask yourself what times x will give you 2x squared, or if you just want to 2x squared divided by x, it's going to be 2x. All right, and normally you line up the x with x, same exponent. You don't have to, because all of this area is the place where you can put your answer. But normally that's how they line it up. And then, you know, when you get here, you're finished off with the problem. So we say x times 2x will give me 2x squared. Now we're going to take this x and multiply it to both terms out here, not just the x. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. All right. And make sure you're careful here. Don't forget to subtract both terms. Notice I put the parentheses there because a lot of times this is where a lot of people make mistakes. They forget to apply the negative to both terms. So they give it to this one. That's what causes this to cancel. But here, negative to a negative, it's going to turn this positive. So that's negative x plus 6, which is going to be 5x. Then you bring down your 3, your plus 3. Once again, you compare your first terms in each. What times x will give you 5x? Or you can just take 5x divided by x. That'll just be 5. Once again, we take this 5, multiply it to both terms out here. That'll be 5x minus 15. Once again, this minus sign needs to be distributed to each term in the parentheses. 5x minus 5x cancels. Then we have 3 plus 15, which is 18. And that's our remainder because we're done here. Final answer is 2x plus 5 plus 18 over x minus 3. So that's the whole answer. All right. Questions before we do another one? All right. Somebody said something. Okay. Yeah, that's understandable. Yeah, some questions may not pop up till you actually start doing them. And then, yeah, you guys know where to find me. All right, so 3w cubed plus 26w squared minus 3 divided by 3w minus 1. Speaking of questions, our next class will be open for whatever questions you guys may have, because this is our last section out of chapter 13. So next class will be an open class for whatever questions. So I won't be doing anything new next class. All right, so we want to set this up using the long division process once again, but also take note that we have a missing term here. And we're talking about x term. We go from x, I said x should be w, not x. Our w to the first power. So we have w cubed, w squared. Then there should be w right here. Then you go to w, or no w at all. So we're missing w to the first power. And so whenever you have a missing term, you're going to need a placeholder. So you do that. just to make sure you're good when you go throughout your process, your long division process, and you go throughout your steps. So that's what that helps you to do. So the way we'll set this up, 3w minus 1. Let me break it down further. So 3w cubed plus 26w squared plus, matter of fact, plus 0w. That's our placeholder. Minus 3. All right. Any questions before we get started? All right. So once again, you compare first terms in each. Say what times 3w will give me 3w cubed. Like I'm running out of room over here. 3w cubed over 3w. Just going to be, there we go. It's going to be w squared. All right. So w squared be the first part of our answer. W squared times 3w. 3w cubed and w squared times -1 is w squared. Subtract. That minus sign needs to go to each term. 3w cubed minus 3w cubed cancels. Negative negative turns positive. So that's going to be 27 w squared. All right. I think we're doing purple, so bring down 0w. Now 0w carries no value. It's just a placeholder to help us when we go about our progression. So now you're looking at first terms in each once again. What times 3w will give you 27w squared? So 27w squared divided by 3w is going to be what, 9w? Once again, take this, multiply it to both terms out here. 9w times 3w, 27w squared. 9w times -1 is -9w. These cancel. That's going to be a positive sign. Negative for negative turns positive. So that's a positive 9w. Bring down -3. Once again, for our last piece, how many times does 3w go into 9w? And that is 3 times. So 3 times 3w, 9w, 3 times -1 is -3. You distribute that negative. Each one of these should cancel, giving you 0, meaning that our answer is w squared plus 9w plus 3. Any questions? Any questions? right, let's look at least one more to make sure we're good. I wonder if they want you guys to do synthetic division. All right, let's see. All right, 9x cubed plus 11x plus 10 divided by 3x plus 2. Guys can start that one while I see if they want you guys or want us to go over synthetic division real quick. They don't focus on it. Okay, so they just do one problem that says use synthetic division. So we'll just focus on long division. And when it says use synthetic division, you could just do the long division process. Either way, it's still the same thing. It'd be different if they actually gave you 3 or 4 problems on synthetic division, but they didn't. So just use long division on that one synthetic division problem, and you'll still be fine. This is, more of a problem process anyway. So first thing we recognize, we have cubed, and then it jumps from cubed to first power, x to the first power. So we have a missing term. And that missing term is x squared. So we need a placeholder for the x squared. All right. So we use a placeholder for x squared, 0x squared. Compare first terms in each. Say what times 3x will give me 9x cubed. So 9x cubed, write it like further forward, divided by 3x is going to be 3x squared. Multiply 3x squared to both terms. So it'll be 9x cubed plus 6x squared. Distribute the negative, so that'd be a negative 6 now. 0 minus 6 is just still negative 6. Bring down plus 11x. So what times 3x will give you negative 6x squared? So that'd be negative 2x. Multiply it to both of these. So it's negative 6x squared minus 4x. These cancel for us. I didn't write it up here. So that'd be 11 plus 4, which is 15x. Bring down your 10. Once again, comparing first terms in each. What times 3x will give me 15x squared, or 15x divided by 3x. Give me 5. 5 times 3x, 15x. 5 times 2 is 10. Subtract them both, and we end up getting 0. So 3x squared minus 2x plus 5 is our answer. All right, any questions? Any questions? So next class will be an open class for you guys to ask whatever questions you want. Anybody still copying before I go to another page? Everybody good? Everybody good? So going back to what we have set up in Connect Math. So, you know, each one of these folders are 2 homework assignments and a test. So make sure you're getting there and doing them. So the last one that I posted was 10 and 11. And we have not had a proctored test yet. So probably should do that at some point, right? Let's see if somebody's here in the chat. The stuff that's due in May. Okay, so let's see. We set up. Those are already past due. And this is May 7th. So when did you send that email? If you sent it Sunday or today, I haven't looked at those emails yet.
Yeah, it was from today.
Oh, okay, yeah, I haven't checked. I haven't taken a look at those yet. So yeah, I'll get to those this evening. So we have, let's see. So mod 1 and mod 2 are already past due. Mod 3, I got this set for March. That's not right. Why is that set like that? Hold on a second. May 7th. These due dates aren't supposed to be like this. So mod 3 and mod 4 will probably be due, if I'm not mistaken, April 4th. I think that's what I talked to you guys about. Because we're talking about 10-week grading period. So let me confirm 10-week grading period. And so that would be our marker. Remember, like last time, 5th week grading period, we had a marker that we would that allowed me to say, hey, okay, this is what you should be doing, or should be able to look at your grades at this point and say, this is what I expect you to have accomplished up to this point. So I believe it's April 4th, which is that Sunday. And I'm trying to do multiple things. Let me edit this assignment because that's not supposed to be March 21st. All right. So, and then just like before, if you need an extension, make sure you get with me so I can give you that extension. Just like 5th week grades, 10th week grades is not the end of the world. It's not the end all be all, but it is what I have to, input. That's what they're asking of me. you know, what are their grades up to this point. So that's why I had to put a date on some things so that we know there's a stamp on this is the marker for us. So Mod 3 and Mod 4 will be due April 4th. I believe that is our 10-week grade period. Let me count that. So it's 1. Yep, should be April 4th. So I haven't changed it in there yet, but that's what it would be for Mod 4 and 5. No, 3 and 4. 3 and 4. So everything up to Mod 4 is expected to be completed by April 4th. And then those last two will be, you know, the final grade, including their final grade. All right. Let me see what y'all are doing. Hold on. Questions on that. Questions on that. Make sure we're good while I take a look at something else. So yeah, some of y'all slacking though. Y'all need to get on this thing. Yep. Y'all need to get on it. Questions before we close. Any questions? Everybody good?
When is all the work due? Is it due before the test or?
Well, the next due date is going to be April 4th. So right now, what has already been, what's already considered past due is Mod 1 and Mod 2. So then we're looking at Mod 3 and Mod 4, which will be April 4th, which is that 10th week grading marking period. And then after that, fifth week, not fifth week, Mod 5 and Mod 6 will be due, and that one will probably just be that May due date. I have to check you guys' final exams. It is that first week in May. So yeah, I can give you to that May 7th. That's a Friday for, you know, everything to be done. That's what I'm talking about, those last two mods. That'll be that Friday.
Okay.
Mm-hmm. All right. Anything else? Anybody else? All right. So try the stuff out, see if you get stuck, see if you have any issues. Then we'll go from there. We only have really one more chapter of new content. That's chapter 14. And then from there, we will be reviewing and prepping for our final exam. Yep. So I see you guys next class. Like I said, don't forget, it will be an open class for questions if you have them. And I will not be doing anything new on next class. All right. So you guys have a good one. Be safe, and I'll see you on Wednesday.